Hi, everybody. This is Dr. J back again. We're going to look at a little program that we wrote in class called Finding the GCD by Euclid's algorithm. And this was done recursively. So we'll go over the logic of the recursion real fast. We'll run it. And then we're going to change it to an iterative solution, because every recursive solution can be written iteratively. The converse, however, is not true. Correct, Andre? Oh, Andre Skipor is here with me today to help out.
Yeah.
Andre, you want to read the comment?
Yeah, of course. This program will compute the greatest common divisor of two positive integers and using Euclid's algorithm.
Okay, and what are the two prototypes?
Yeah, we have two functions. The read data, which is read the input of two positive integers, and we have the functions for the Euclid algorithm.
Okay, now with the read data, it's very important that we pass by reference, not by value, right?
Mm-hmm.
By value, it makes a copy of the parameter being passed, and it doesn't really affect the local variable in main.
Mm-hmm.
So that would be useless to us. All right, so let's look at main. You want to read through main?
Yeah, of course. We have two integers, m and n, and we ask users for these two integers, and we're using the read data function, which is pass the values. Is correct, Professor?
Yeah, you're passing the by reference.
By reference,
M and
we're
N.
passing the address to
Yeah,
this information.
that's correct. And then?
And then we go into the Euclid function, and we're trying to figure out the great common divisor.
And we print it out and call it at the same time as we print it.
That's
Okay.
correct.
Now let's look at read data function. What's the precondition and postcondition?
The precondition is two local variables defined as integers are being passed by reference, and postcondition, the two local variables being passed will be altered by asking the user for data and must be positive.
All right, so the must be positive necessitates some kind of a loop to check.
Yeah.
So you want to read that loop?
Yeah, we do the do-while loop. So inside it, do put cout, enter two positive integers separated by space, and we see in these two integers, and we keep asking the user to input it again if the one of these or two of these integers will be negative or equal to 0.
Correct. So notice we're using an or for a change. In
Yeah.
most of our conditions to date, we've been using an and.
Mm-hmm.
So we give the or a break.
Yes.
And let's look at the actual function that does most of the work. Look how small that is.
Yeah, it's
Go ahead.
pretty cool. So we're using the recursive function. So we inside the Euclid function we have one statement, like if statement. If
Well, the base case.
the base case,
yeah.
if n equals to 0, we return m, and otherwise we use the Euclid function again.
Right. And according to Euclid, the GCD of m and n is the same as the GCD of n and m mod n. That makes a smaller version of itself. Hence, it's a divide and conquer algorithm, the base case being n equals to 0. But the reason we had to make sure m and n were positive the first time we called it is because it would make no sense that the GCD of 50 and 0 is 50, which is not true.
Mm-hmm. That's correct.
Yeah, so we had to be careful about that. If we were to write a precondition, well, it really got confusing, so I figured it was better not to write a precondition.
Okay.
Now, the only thing that we have to change to make it iterative is the recursion. Get rid of rewrite the Euclid's function.
Mm-hmm.
So first let me save it as another version. File, save as. Instead of Euclid CPP, I'll call it Euclid iterative, ITER. .cpp, so we know the difference. you want me to just erase and we start from the beginning?
Yeah.
Okay, so we have to write Euclid's function that determines the GCD of m and n. We're going to start by int r equal m mod n, and we keep going until r is 0. So we need a loop, and then we're going to return the last value of r before it became 0, which is n.
Yes.
All right, so let's do the while loop. While r is greater
Yeah.
than 0. And what are we doing in here? We're doing m equal n, and n equal r, n equal r, and we have to redo r again. R equal m mod n, right? M mod n. And we keep doing that until, oh no, it's a while loop. Now we return n, and let's test it. Looks like I have an extra right paren. Okay, clean compile. Let's put in 320 and 60 and see if we get 20.
Yeah.
Okay, let's do it the other way. 60 and 320 and see if we get 20. $60 and 320. Okay, so that all is well that ends well. So that looks pretty good. No point really testing any further. So I think we should stop right here. What do you think?
Yeah, you're absolutely right.
Yeah. You gotta know when to quit. All right. So